I ever gonna make it to graduation?
Well, Dorothy, all you have to do is follow the yellow brick road and finish this Calculus FRQ number 6. Good luck.
Thank you, Glenda.
Absolutely.
Man, I really do wish I had a brain. I mean, for something else other than calculus. That I can do, but...
Let's get to starting this FRQ. FRQ number 6. Consider the curve given by the equation 6xy equals 2 plus y cubed. A. Show that dy dx. I don't even know what dy dx is. I do. Looks like I found somebody to help me. Let's see if she can do this. You can really do part A?
Yes, well, we're gonna find out.
For part A of this problem, you're asked to show that dy dx, the derivative of the original function, is equal to 2y over y squared minus 2x, and the original function is given in implicit form, which is 6xy is equal to 2 plus y cubed. And as you can notice, there's a y on both sides, so you must use implicit differentiation to prove that dy dx is indeed what is given in A. To start out with your implicit differentiation, you're going to want to multiply the entire function by d dx. So as you can notice, there's an x times y, which you're going to want to use your product rule to differentiate. And you're going to get 6y plus 6x dy dx is equal to a 3y squared times dy dx. And you can notice that I multiplied by dy dx because that's the chain rule. Proceeding this step, you're going to want to place your dy dx terms to one side of the function. So I got a 6y is equal to 3y squared times dy dx minus 6x dy dx. After this step, you can divide your entire function by 3. You can also factor out your dy dx at this time, so you're left with a 2y equals dy dx times y squared minus 2x. And of course, College Board allows you to leave this function in this form, but you can also take that dy dx and place it on one side of the equation to prove that dy dx is equal to 2y over y squared minus 2x. For this problem, 1 point is given for the actual showing your work for implicit differentiation, and another point is given for the verification, so you can either leave it in this form or the other form. Common mistakes for this part include things such as not including your chain rule. In this sample problem, the student did not do implicit differentiation, so they didn't gain that point, and therefore they were not able to gain the second point for verification.
You did solve dy dx. You're so good at math.
Oh, thank you. You know, just sometimes, no, I'm not that smart.
Let's go.
Okay. Such a beautiful day.
Oh, they look like they're having so much fun. I wish I was a part of that.
Time for part B. Find the coordinates of a point on the curve at which the line tangent to the curve is horizontal, or explain why no such point exists. It doesn't exist? How are we supposed to find it if it doesn't exist?
I don't know. I don't got brains for this.
Maybe I can help.
Really?
To solve for part B, for the line tangent to the curve to be horizontal, 2y must equal 0, meaning that y is equal to 0, but y squared minus 2x cannot equal 0. To then find x when y equals 0, you simply plug in the 0 into 6xy, which is equal to 2 plus y cubed, but then find out that 0 is not equal to 0. 0 is not equal to 2, meaning that no point exists when the line tangent to the curve is horizontal. The point breakdown for this section is the first point is earned by identifying any of the following being equal to 0, and the second point is given for the answer with reason. A common mistake from example 2 on College Board can be getting only the first part, which is y is equal to 0, but then plugging it into your dy dx and getting the coordinate point of 0, 0, and this only gets you 1 point because there's no conclusion and there's no stating that no point exists.
My heart feels so full right now. If only I had one.
Well, we're one step closer to graduation.
Yippee!
Let's go! Part C. Find the coordinates of a point on the curve at which the line tangent to the curve is vertical, or explain why no such point exists. Anybody?
Go me, yeah.
Who's that? Hey there! Yeah, you! Do you happen to know calculus?
Are they talking to me? Or is this like the time where I thought Paco was talking to me and he wasn't? No one's ever asked for my help before. I'm like too scared to go over there. But it really seems like they need my help, so I need it. Okay, I'll go.
Any chance you can solve this part C?
I think maybe I could try.
Part C. Find the coordinates of a point on the curve at which the line tangent to the curve is vertical, or explain why no such point exists. A derivative being the slope of a function tells us that the slope is vertical when the denominator of the derivative is 0. You set y squared minus 2x equals 0, and you find x as a function of y. This means later on we can plug in whatever value we find for y or x to find the other value. Substitute y squared in for x in the original function. As we simplify, we should end up with y equals 1, meaning that 1 is the y coordinate of the function at the point where the slope is vertical. We're plugging in 1 into the original equation to then solve for x. As we simplify, we should end up with 1/2, meaning 1/2 is the x coordinate at the point on the function where the slope is vertical. The College Board scores this 1 point for the denominator of the derivative to equal 0, 1 point to sub in one value that is a function of the other value to then solve for both coordinates, and 1 point for the answer 1/2 1 as your coordinates. So this person would get the first point for setting the denominator of the derivative equal to 0. They solved for y as a function of x, which is different from how we showed it earlier, but they thought that that was enough to show what the y coordinate was, and they also got the incorrect x coordinate, so they only get 1 point. Most mistakes come after y squared minus 2x equals 0. A lot of people assume that one of their coordinates is going to equal 0 because if they think if something is set equal to 0, then one of their answers has to equal 0, which is, of course, isn't always true, and here definitely isn't true. A lot of other various different mistakes can happen. It just has to do with the confusion of having two different variables that you don't know either of them, how to solve for both of them at once.
Wow, I actually did it by myself this time. Last time I wasn't even able to get my pen on paper.
We knew you could do it.
I feel brave already. Let's get this finished.
Let's go.
Oh no, the gates are closed.
No need to worry. Glenda told me this would happen. She said all I have to do is ask Oz to let us in. Oz, are you there?
This is College Board.
Well, College Board, can you open the gates for us?
You forgot one part of the completion process.
What do you mean?
Here.
Part D?
Solve it or you're not graduating.
Oh no. I can do this! Part D. A particle is moving along the curve. At the instant when the particle is at the point 1/2, -2, its horizontal position is increasing at a rate of dx dt equals 2/3 unit per second. What is the value of dy dt, the rate of change of the particle's vertical position at that instant? This problem is asking us to find dy dt. In it, we are given dx dt equals 2/3 unit per second at the point 1/2, -2. To start, we take the equation of the curve, 6xy equals 2 plus y cubed, and we take the implicit differentiation of that, so the ddt. You have to move the 6xy because of the xy multiplied together, and it comes out like this, equaling the 0 because of the 2, 3y squared, and don't forget the dy dt. Here, we've now plug in what we are given. Plug in the -2 for the y, the 1/2 for the x, and the 2/3 for the dx dt. You can solve from there, basic algebra, to solve for the dy dt equaling -8/9 unit per second. Our first point comes from using implicit differentiation with respect to t of that original equation. Our second point is for our answer. If you have an answer with no work, you do not get this point. This student sample used implicit differentiation, but differentiated wrong because they forgot to take the derivative of the 2, and get it to 0. So they only get the first point in this case because they're using implicit differentiation, but did not get the correct answer. A common mistake for this problem is using implicit differentiation with respect to x instead of respect to t. This would mean using the dy dx that you found in part A instead of taking the ddt of the original equation. This student did this and plugged in 1/2 -2 and got an incorrect answer.
I did it! Let's go graduate!